We are JTB Squared, and we are a water consulting firm for civil projects based in Atlanta, Georgia. We specialize in providing expert guided solutions and strategies related to water management. We oversee the planning, execution, and monitoring of water projects from inception to completion. Here are the contributions. So Jordan Botha did the pipe and inlet design and analysis. Brown and Reiner did the drainage boundary delineation. I did the presentation, written responses, and citations. And Brendan Perez did the time concentration calculations. This presentation outlines a proposed site for a brand new stormwater management system for a multifamily residential project in Atlanta, Georgia. It details the infrastructure design necessary to effectively handle rain runoff and comply with Georgia regulations, including those in Article 10 of the Post-Development Stormwater Management and Georgia Stormwater Management Manual. And I'm going to pass it off to Brianna.
Hello, my name is Brianna Greiner, and I'm going to be discussing both the existing and proposed descriptions and conditions of the site. So for deliverables, the slide below will contain the deliverables to be submitted for phase 1 of this project. Most importantly, including a labeled site layout, description of the existing and proposed sites, as well as the design criteria and the methodology that led us to our final design tables. For our existing site, the site to be developed consists of a greenfield that is bordered by roads on its periphery that offers a range of prevailing site conditions crucial for construction planning. The topography of the site features relatively flat terrain with some elevation differences, and these slightly steeper slopes will be seen alongside the property line. The site has no vegetation other than grasses and sporadic shrubbery, in which there is no current evidence of erosion. Utilities and existing pipelines consist of water supply lines, sewer systems, and electrical infrastructure, which are accessible from the neighboring roads, making connections for construction easier to design for. Our team found that overall, the existing site conditions provide a promising foundation for the development of the greenfield lot with opportunities for thoughtful integration of the proposed infrastructure. And it's worth mentioning that the existing site is approximately 10 acres and displays a range of dynamic features that enhance its overall suitability for the proposed development. The figure it provided is our existing site prior to any construction, and it contains the elevation, contours, and boundary needed for design. A larger portion of stormwater from the proposed design will exit the site and enter into a detention pond that's going to be designed for in phase 2 of this project. For your proposed site description, the site is classified as residential, and it's consisting of 2 parking lots and 3 courtyards and 2-story buildings with 132,753 square feet. For stormwater management, the site will be comprised of concrete pipes due to containing a higher hydraulic performance in comparison to other pipes, with either 12 or 18-inch pipes chosen. For the site conditions, the proposed site is primarily covered by concrete and asphalt and apartment complex roofing. Due to this, we're going to have higher runoff coefficients, mainly ranging from 0.6 to 0.9, and there's low grass coverage along the site and very few watersheds with grass coverage. There is 23 proposed pour points in total. This slide is going to contain our proposed residential complex that will contain pipes and more inlets that are seen in the next few slides as well. Now we're switching over to Brandon.
Hello, I'm Brandon Perez, and I will be discussing the design criteria as well with our watershed delineation. So let's get started. We analyzed historical rainfall data to assess the frequency and intensity of precipitation events in this area. This information helped us estimate the volume of water that enters the site during our storm. From there, we went to the Georgia Stormwater Manual to determine our design criteria. The maximum hydraulic gradient should not produce a velocity that exceeds 15 feet per second. The minimum desirable physical slope should be 0.5%, or the slope that will produce a velocity of 2.5 feet per second when the storm sewer is flowing full, whichever is greater. All storm drains should be designed such that flow velocities will increase progressively throughout the length of the pipe system. Upper reaches of a storm drain system should have flatter slopes than slopes of lower reaches. The Georgia Stormwater Manual also deduced that the fact that there should be a minimum of 5 minutes for time of concentration with maximum sheet flow length of 50 and or 100 feet, depending on site conditions. For our design methodology, we used rational method for pipe design. For time of concentration, we used TR55 method or SES. For runoff coefficients, we used this volume 2 of the Georgia Stormwater Manual. For precipitation, we use 3.8 inches obtained from the SSA and IDF curve from NOAA Atlas 14. Our investigation focused on assessing the water dynamics of our site. Through the survey data collected, we aim to understand how water flows through the site and identify potential risks. One of the primary findings of our report is the importance of topography and influencing water movement. The site's terrain plays a crucial role in determining where water accumulates and how it drains. Based on our site and proposed site, we generated 23 watersheds with 23 pipes. We analyzed historical data to assess the frequency and intensity of precipitation events in this area. The highest time of concentration calculated was in sub-basin station 2 with 13 minutes and 29 seconds. And our minimum time of concentration as determined by the Georgia Stormwater Manual to be 5 minutes, specifically in areas where there was buildings or a majority of the site was just roof. For inlets, we calculated there to be 24 inlets. The manufacturer to be FDOT with the type being DBI type A on SAG. We also determined that there should be 3 outfalls, three of them which are going to be located in our southern part of our site. Now I'll pass it off to Jordan.
Thank you, Brandon. I'm Jordan. I'm gonna go through the analysis here. So here's a list of all the pipes we have associated with this project, along with the inlets and outlets for each pipe. We also have the inlets and outlets elevation for each pipe as well on the slide. Here's some more information about each pipe. As stated earlier, design criteria requires the slope of the pipes to be a minimum of 0.5%. As can be seen here, all pipes meet this criteria. We can also see the shapes of the pipes, which is circular along with the diameter and material for the pipes. For pipe sizing, most of the pipes at the beginning of the drainage systems were sized to 12 inches and were upsized to 18 inches once conditions required us to do so. As Brianna stated earlier, concrete was used because of its advantages compared to other pipe materials, and the concrete piping Manning's coefficient is 0.015. In this table, we can see the runoff in cubic feet per second for each watershed in each analysis. As can be seen, runoff is quite low, with a maximum of 3.18 for substation 31 in the 100-year analysis. For this report, we ran 6 different analyses: a 1, 2, 5, 10, 25, and 100-year report. Here are some of the corresponding peak flows and velocities for each analysis. All velocities for the analyses are above the minimum 2.5 feet per second and fall below the maximum 15 feet per second from the design criteria in the Georgia Stormwater Manual. Thank you.
Thank you, Jordan, for the explanation of our analysis. As we discussed, our design meets local ordinances and regulations. So in conclusion, we think this is an appropriate design for the need of this complex. Thank you for entrusting us to design this endeavor. If you have any questions, please don't hesitate to contact us, and we hope you have a wonderful day.